Evaluate each limits. I'm Anil Kumar, and in this video we'll try to understand how to evaluate limit of a given function. The first one is limit of x squared minus x plus 1 when x approaches 3. Then we have limit of a quadratic function 2x plus 1 times x minus 1 when x approaches minus 1. The third one is a rational function where x squared minus 4x plus 4 is divided by x plus 2. We need to find limit as x approaches 2. And the last one here is again a rational function. Limit of x squared minus 4 divided by x minus 2 as x approaches 2. First step in evaluating limit is substitute the value for what x is approaching. If the function is continuous at that point, in that case, limit of the function is same as value of the function, correct? So for a continuous function, a function approaches the same value as the value of the function at that point. So that's kind of key. So first step is just substitute x equals to 3 in your function. So if I do that, what do I get? I get 3 squared minus 3 plus 1, which is 9 minus 3 plus 1. 6 plus 1 is 7. So my answer is 7 for this one. For the next one, if I substitute minus 1, what do I get? 2 times minus 1 is minus 2. So I get minus 2 plus 1. And here I get minus 1 minus 1. That gives me minus 2 times minus 1 is minus 1. And this is minus 2. And that gives me an answer of 2. So limit of the second function as x approaches minus 1 is 2. Now for the third one, I'll substitute 2 here. So 2 squared is 4. 4 times 2 is 8 plus 4 over 2 plus 2, right? So let me write 2 plus 2 for the time being. So what do I get? 4 plus 4 is 8. 8 minus 8 is 0. And 0 over anything is 0. 0 is a valid number, and so limit of this function is 0 as x approaches 2. Now let me follow these steps in the last example. Limit of x squared minus 4 divided by x minus 2 when x approaches 2. So if I substitute 2 here, then what do I get? I get 2 squared minus 4 divided by 2 minus 2. Now 2 squared is 4. 4 minus 4 is 0. 2 minus 2 is also 0. Now 0 over 0 is indeterminate, and it also indicates that there is a common factor in both numerator and denominator. Well, you should not jump to the conclusion that limit does not exist. Now in such a case, we need to factor, simplify, and then find the limit, right? So that is what the thing is. So in case the function is continuous at the point we're trying to find the limit, you can get the answer by substituting. Otherwise, you may follow some techniques. In the coming videos, we will understand what kind of techniques should be applied for a rational function, for functions where we have square root, or different kinds of functions, right? So in this, the technique is to factorize. So let us factorize and then find the limit of this function. So this is how you should be solving this particular question. So once you get 0 over 0, we know it is indeterminate. So the way is, we need to factor. X squared minus 4 is x plus 2 times x minus 2 divided by x minus 2. As you can see, we do have a common factor in numerator and denominator that cancels off, right? And so we are left with limit of x approaches 2 for x plus 2, right? So we are approaching 2. Remember, it is not equal to 2. Limit is you are approaching 2. Since you are very, very close, then the value which you are approaching will be what? Value will be, now you can substitute 2 here. It will be 2 plus 2, which is equals to 4. And that is how you find limit of such a function. So whenever you get 0 over 0, then you may look for a common factor, cancel it out, and then do the needful. Now let me sketch this graph for you and make you understand how we get this limit of 4 if we analyze the graph, right? So I'll do it right here in the center. Okay, so what we found here is that there was a common factor. This common factor always is because of a hole, right? So there is a hole, and the function basically is equal to x plus 2, where x is not equal to 2, right? So x plus 2 will be a graph with y-intercept at 2 and slope of 1. So let me draw here a line like this, right? Now the restriction here is that x is not equal to 2, right? So let us say this is x value of 2. Then at this point what we have, actually we have a hole. It is not filled in. So the graph is actually like this, right? The reason why we got 0 over 0 is because there was a hole at this point. The function is not continuous, right? That is why you got 0 over 0. That also indicates that there is a common factor of x minus 2 in the numerator as well as denominator, which made it 0 in both numerator and denominator. But well, limit is not the value at that point, but the value function approaches. Do you see that part? Now you can see from here that whether you approach from the left side or from the right side, you are approaching a value of 4, and therefore limit of this function at 2 is 4, and that's why 4 is the right answer for the given question. So this limit is actually equals to 4 as we have calculated here. So in the coming videos you will understand in such cases where you get 0 over 0, how do we find limit? So go through the playlist where we have mentioned indeterminates. So all these functions where after substitution you get 0 over 0, they are called indeterminates, and we use techniques like factoring and rationalization to solve. I hope that will help you to understand the topic. Thank you and all the best.